Hi, and welcome to DLC's video tutorials. Today we are going to graph systems of equations. We are going to find the solution to a system of equations by graphing. Okay, so what is a system? We all know what an equation is, but what is a system of equations? Well, a system in the English language is it's well, let me give you an example. If I say your high school, is that its own facility, its own structure, its own place, or is it part of a system of schools? Well, if the high school serves only 9th through 12th grade, then it's part of a system because you have an elementary, a middle school, and a high school. That's if you're in a small town. If you're in a big city, it's part of a bigger system with many elementaries, many middle schools, and many high schools. Just like the University of Texas, San Antonio. That is not its own private, its own university with its own identity. It is part of a system. It is part of the University of Texas system. Okay, so what we're going to do today is we're going to solve a system of equations by graphing. And the first thing what we have to do is we have to solve both equations for y. We have to have both equations in slope-intercept form, which is y equals mx plus b format. Okay, so let's go ahead and start. Let me get my pen. Okay. So, this is the first one. Let me go ahead and solve. I'm just going to rewrite it here. And then I'm going to go ahead and solve for y. So I'm going to subtract 2x from both sides. Okay, that's gone. So negative y is equal to negative 2x plus 8. Then to get rid of the negative, it's kind of like saying negative 1y. So I'm going to divide everything by negative 1. You could also just change the signs of every term. So y is equal to negative 2 divided by negative 1 is a positive 2. And 8 divided by negative 1 is a negative 8. Okay, so I have one equation. Now let's solve the second equation for y so that we could have it in slope-intercept form. So I'm going to subtract x from both sides. That zeroes that out. So now I have y is equal to negative x plus 1. Okay, so here are my two equations in slope-intercept form. Let's graph, doesn't matter which one we graph first. Let's go ahead and graph this one. So we're going to start with the y-intercept, which is plus 1. So you start at the origin, go up 1, and that's our first point. And then from there, we're going to find more points using our slope. Because there is a negative in front of the x, it's like saying negative 1x. Therefore, our slope is negative 1. Negative 1 is the same as negative 1 over 1. So from the point, we go down 1, negative, and then 1 to the right. Down 1, 1 to the right. Down 1, 1 to the right. Or what we could do is go up 1 and 1 to the left. Up 1 and 1 to the left. Because negative 1 over 1 is the same as 1 over negative 1. Because at the end, it all equals to negative 1. Okay, so this is our first line. What I'm going to do is going to draw a line. Okay. Let me just fix it just a tad. Right there. Oops. I go further. Okay. Now we're going to graph our second equation. So we're going to start at negative 8. Let me go ahead and scroll down. Okay. So negative 8, we start at the origin, go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And from there we're going to find more points or plot more points using our slope. Our slope is 2. It's the number in front of the x, but 2 is the same as 2 over 1. So from here, we go up 2, and then 1 to the right, right? It's rise over run. Up 2, 1 to the right. Up 2, 1 to the right. Ah, looks like there's our solution. Up 2 and 1 to the right. Okay, let's go ahead and draw our line. Okay. So our solution is the point of intersection. And if this was completely straight like it's supposed to be, we would see that, okay, it looks like that's fine. Looks like it's, okay, let me just move that just a little more. Okay. So the point of intersection is the solution. And what is that point? Well, that point is, so it's start at the origin, it's 1, 2, 3, 4, oops, I'm sorry, 1, 2, 3. So our x coordinate is 3, and our y coordinate is 2, negative 2. The point of intersection is 3, negative 2. That is the point, or the set of coordinates, that satisfy both equations. It is the point that lies on this line and that lies on this line. Okay, it is the point of intersection. It is the point that lies on both lines. Therefore, it is a set of coordinates that satisfy both equations. What do I mean by that? Well, if we plug this for x and this for y, because this is the x coordinate and y coordinate, into either the first equation or the second equation, we will satisfy the equation. So let's do the first one. So 2 instead of 2x, see 2x minus y equals 8. Instead of 2x, it's 2 times 3. Minus y, instead of minus y, it's minus a negative 2, equals 8. 2 times 3 is 6, minus a negative 2 is plus 2, equals 8. Is that true? Yes. Okay, let's plug it into the second one. Okay, so instead of x plus y equals 1, we're going to have 3 plus a negative 2 equals 1. 3 plus a negative 2 is the same as 3 minus 2. 3 minus 2 equals 1. That's true. This is our solution. Okay? This is our point of intersection. This is our set of coordinates that satisfy both equations. And that is how you solve a system. Let's go ahead and do one more example. Okay, so let's move a little faster now. Okay, so I'm going to rewrite this as 2x plus y equals 2 on over here so that I could solve it, have more room, more space. I'm going to subtract 2x from both sides. That's gone, so y is equal to negative 2x plus 2. Now the second equation, I subtract x from both sides. So I have negative y is equal to negative x plus 4. I could divide everything by negative 1, or I could just change the signs because that'll give me the same result. So y is equal to x minus 4. Now I have both equations solved for y in slope-intercept form. Go ahead and plot the first one. So I start with negative 4. So I start at the origin, go down 4, 1, 2, 3, 4. Then I'm going to use my slope to plot more points. There's a 1 right here, so it's 1 over 1. So I'm going to go up 1, 1 to the right, up 1, 1 to the right, up 1, 1 to the right. There's my line. Go ahead and draw my line right now. Okay. Okay. Now let's plot the second one. Okay, so I start at plus 2, start at the origin and go up 2. Then from there, okay, my slope is negative 2, which is negative 2 over 1. So I'm going to go down 2, 1 to the right, down 2, 1 to the right. There's my solution. Down 2, 1 to the right. My solution is a point of intersection. It's also the set of coordinates that satisfy both equations. Okay, so I'm going to plot that. Oops. Okay. This is what I get for doing it too fast. Okay, so right there. There you go. So the point of intersection is my solution. Okay, so that is 1, 2, 1, 2. So it's 2, negative 2. So we could check that by plugging this set of coordinates into the first equation and the second equation. So let's go ahead and just do the first. So 2x plus y equals 2. 2 times 2 plus y, which is negative 2, equals 2. Okay. 2 times 2 is 4. 4 plus the negative 2 is minus 2 equals 2. Is that correct? That's true. Second one, x minus y equals 4. So instead of x, we go 2 minus a negative 2 equals 4. 2 minus a negative 2 is 2 plus 2. 2 plus 2 equals 4. That's correct. 2, negative 2 is my solution. Okay, now you won't always have your point of intersection. Sometimes you could have parallel lines. And when you have that, your answer is no solution because there is no point that is on both lines. There is no set of coordinates that satisfy both equations. Okay, let's do the first one. Let's solve it for y. I'm going to write it over here so I could have more room. Let's subtract x from both sides. Zero that out. Negative 3y is equal to negative x plus 6. Subtract everything by negative 3. So y is equal to, right here it's 1 over 3x. There's an imaginary 1 right there. Negative divided by negative is a positive. 6 divided by negative 3 is negative 2. Okay, now the second one. Okay, so x minus 3y equals negative 3. Subtract x from both sides. So I could zero that out. I want y by itself. Negative 3y is equal to negative x minus 3. Divide everything by negative 3. So y is equal to 1/3 x plus 1. Okay, whenever you have the same slope, you don't have to graph it. The answer is always going to be no solution. If you have the same slope, then you have the same steepness for both lines. They're just at two different locations. And if you have the same steepness for two different lines, then that means they're parallel. Okay, let's go ahead and graph let me erase this because that's an ugly example. Okay, let's start at plus 1. So start at the origin, plus 1. Your slope is 1/3. So we're going to go up 1, 1, 2, 3 to the right. Up 1, 1, 2, 3 to the right. There's our line. Okay, let's do this quick. Okay. Not exactly perfect, so let's make it perfect. Okay. There we go. Okay, now our second one, negative 2. So start at the origin, go down 2. That's your first point. That's your y-intercept. Now your slope is 1 over 3. So up 1, 1, 2, 3 to the right. Up 1, 1, 2, 3 to the right. These lines will never intersect. So therefore, there is no solution. Because your solution to a system of equations is a point of intersection on a graph, or the set of coordinates that satisfy your system, both equations. So this is, these are both parallel. Now this isn't perfect. There you go. It's a little more parallel. Okay, so the answer to this would be no solution. There is no point of intersection. Okay, so that is the end of the lesson. Hope this helped. Go look on your studies. See you later. Bye-bye.